Welcome to The Explainer. Today, we're unpacking something absolutely fascinating. On the surface, what we're looking at is just a standard middle school science curriculum. But underneath, it's a brilliant, highly structured educational framework that literally disguises a masterclass in human psychology right inside a high-stakes ecological crisis. It's a simulation called the Reef. It really starts with this exact question. How do you teach a sixth grader to outsmart their own brain? I mean, you can't just hand a kid a dense textbook on cognitive psychology and expect it to stick, right? Instead, the creators of this framework use something called discovery-first pedagogy. Basically, the students are thrown into an experience where they stumble over their own mental blind spots first, and they only learn the actual names of those traps after they've already fallen into them. So, how does this whole experience actually work? Well, the tangible mechanics of the Reef are brilliantly straightforward. Small teams of students are put in charge of a coral ecosystem for 10 simulated days. They're handed a strict $15,000 research budget. Every single day, they have to track 9 specific health metrics, things like water temperature, parrotfish populations, and water clarity. And all the while, they have to manage the intense pressure of a local economy that relies heavily on keeping tourism wide open. Which brings us to our first major concept, a Trojan horse for minds, and the real curriculum hidden in the coral. Let's look at reading the calm reef and the danger of the baseline. So the simulation kicks off on day 1, and the data they receive starts out perfectly calm. Every single metric is beautifully green and healthy. But, this is completely deliberate. It's an interpretive trap specifically designed to build a false sense of security right out of the gate. Think about how this unfolds. That all-green day 1 baseline builds massive false confidence. The students write down that the reef is totally fine, managing it is going to be a breeze. But then day 2 hits, and it introduces these tiny, kind of ambiguous shifts in the numbers. Water clarity drops 1 meter. Algae ticks up 1%. Okay, let's dive into this. Notice how the students process the math here. Sea turtles drop from 5 sightings to 4. Mathematically, that is a massive 20% drop. It sounds absolutely terrifying on paper, but is a drop from 5 turtles to 4 an actual ecological crisis, or is it just, a normal Tuesday on the reef? The students have to decide right then and there if this is a real trend or just daily noise. By day 3, we enter the bias obstacle course. What happens when the data splits? The numbers become genuinely mixed. Some metrics bounce back to normal, while others start trending poorly. This ambiguity is perfectly engineered to force students to start picking sides and constructing early narratives. And this is where we formally hit our first major psychological trap, confirmation bias. The teams that decided the reef was totally fine on day 1 will suddenly cherry-pick only the good day 3 data to confirm their initial guesses. Meanwhile, the students who panicked over the sea turtles on day 2, they'll cherry-pick only the bad data. It's the exact same spreadsheet, but because of confirmation bias, it generates completely opposite narratives. Then, on day 5, the simulation introduces incredible human tension. Meet Maria Santos. She's a perfectly scripted authority figure, the local tourism board director. She drops a written statement on the students demanding they keep tourism open despite the worsening ecosystem data. She points to her 18 years of experience and calmly tells them they're just overreacting to seasonal variation. Put yourself directly into the shoes of a 6th grader facing this incredibly stressful, high-stakes standoff. You've got 5 days of worrying spreadsheet data. She has 18 years of lived experience and the entire weight of the local economy on her shoulders. Who are you going to trust? This perfectly defines the exact psychological trap Maria's presence induces: authority bias. The students feel this immense pull to just defer to her. But the simulation pushes them to ask a much harder question. Does her impressive past experience automatically make her right about this specific, unprecedented, rapidly changing data set? This leads us to a highly counterintuitive truth where the boring choice wins, especially when contrasting strategies under pressure. As the simulation deepens, we see that to actually succeed and save the ecosystem, doing the boring thing is really the only way to win. Let's contrast the strategies. On one side, you have the aggressive fixers. They panic early. They blow their limited budget on temporary algae removal, effectively just treating the symptoms. By the time the real crisis hits, their bank account is totally empty. On the other side, we have the cautious monitors. They take the boring path. They trust the data, implement moderate 25 to 50% tourism restrictions, and crucially, they save their money. When the massive Day 7 coral bleaching crisis inevitably hits, it severely punishes those reactive teams. And as their reefs start collapsing, a new trap triggers: optimism bias. The teams desperately try to downplay the dying coral by telling themselves, well, 12% bleaching isn't that bad. It'll probably bounce back tomorrow. They underestimate the severity simply because it hasn't reached total catastrophe yet. Now we confront the illusion of control and the importance of separating cause from symptom. The absolute crucial point here is distinguishing between what the students can actively manage and what they absolutely cannot. This brilliantly illustrates the core ecosystem cascade. Step 1. The water temperature rises. That's the root cause, but obviously students cannot control the ocean's temperature. Step 2. The warm water causes parrotfish to decline. Step 3. Without parrotfish to eat it, algae overgrows. Step 4. The coral dies. The algae growth is merely a treatable symptom. The teams that try to control the uncontrollable temperature lose. The teams that address the symptoms while protecting the ecosystem from extra stress, they survive. Which brings us to the ingenious Day 9 twist. Think about the temperature trend here. On Day 9, the water temperature finally drops naturally due to a change in the weather. But the students don't immediately realize it's just the weather. They look at their frantic spending and policy changes from Day 8 and think, we did it! We saved the reef! This perfectly encapsulates our final primary bias, the illusion of control. The students actually take credit for the weather. It's a brilliant, humbling lesson in confusing correlation with causation and learning to recognize when an outcome was actually determined by forces totally outside of your hands. Let's see how all of this builds into creating patient decision makers in our metacognitive climax. The discovery-first architecture finally pulls back the curtain completely for the students. Think about the narrative timeline they just survived. They went from Day 1's false confidence straight into Day 5's clash with authority, pushed through the brutal Day 7 bleaching crisis, and finally arrive at Day 10. On this final day, there's no new data. Instead, they are finally given the canonical psychological names of the biases they've been stumbling blindly over for a week and a half. And here is the actual curriculum of the framework. Managing the coral was simply a beautiful vehicle to exercise these 8 crucial metacognitive skills, forming the acronym PATIENCE. From emotional regulation under pressure to information discernment, the curriculum wasn't really about coral at all. It was about training young minds to pause, reflect, and evaluate exactly how they make decisions under genuine, high-stakes uncertainty. This explainer leaves us with a final, memorable thought that the students are asked on their last day. It's really a question for all of us. When facing a crisis in your own life, do you read the data before you read the panic? Do you update your plan when the evidence contradicts it, or do you just explain the data away? And perhaps most importantly, do you honestly name what you cannot control? Take some time to think about the psychological traps in your own daily decision-making. Thanks for joining me on this explainer. I really hope it left you with plenty to think about.